everyone, welcome to a new session of Big Data Boutique Ask Me Anything session. Here we have Anton Rodriguez, who is an expert in event streaming, real-time processing framework, plenty of experience with Kafka, with Spark Structured Streaming, some projects with Flink. He's going to speak about schema management, how to do it, what are the file formats. So let's start. Well, so today we are going to speak about JSON, Avro, Parquet, what format is better for your use case. Then we are going to go to cover schema evolution, so how to evolve a schema without break compatibility with other systems using your data. And then we are just going to comment AsyncAPI as a solution to organize and to implement better schema management in event streaming architectures. So let's start introducing Avro, Parquet, and JSON, okay, and why they are so important. So basically they are very three popular file formats or data formats used in big data technologies. Okay, the thing is they have some positive things and negative things depending on what you want to do. Okay, so let's start covering JSON. In this case, I'm going to speak about JSON-line. JSON-line is basically JSON where you have each JSON record in one line, and in a file you can have many JSON records. Okay, it's a very typical format used by Spark or to read from data files. The characteristic or the main characteristic of JSON, it's a text format. That means you can open it with an editor and you can just read it. It's quite easy to read by humans. It's not designed to be read by humans, unfortunately, but it's perfectly possible. Okay, because it's so good in that aspect, it's not so good being parsed by machines. Okay, it works well, but it's not so efficient as other formats. The thing is the default format when we are speaking about JavaScript, the browser, REST APIs, and all that stuff. Okay, so not in the big data area, but in the web area, it's probably the most popular way to structure organization data. So that means the support from libraries, platforms, languages, programming languages, it's really good. You have a lot of libraries which are quite efficient to parse JSON files. But the limitations of a text format are there. So if you want to search inside a bunch of JSON files, it's going to take time. It's not easy. Okay, and there are some initiatives. The most popular is by far JSON schema, trying to have a schema in top of your file, so it's not just a free format. So you know what you can expect when you are processing a record. Okay, that's something you can achieve with JSON schema. It's more popular in terms of APIs, with things like One API and Swagger and so on and so forth. They are using this JSON schema for that. But you can definitely also use it in big data projects to track how your data is evolving. Okay, so the thing is, it's not designed for that. So it can help you to evolve your data, but it doesn't provide really specific features in that regard. The other popular format we have is Parquet. Okay, well, Parquet is extremely popular in the Hadoop ecosystem, and there is a reason for that. It's a columnar storage format. So what this means is, first, it's a binary format. If you open a file, A Parquet file, you are not going to understand anything. You need to deserialize it, transform it in a text format to be able to read what is inside. Okay, but being binary means the performance is going to be a lot better because it's designed to be processed by a machine. So you are only storing the information in a way needed for a machine to understand what is inside. It's not oriented in rows but in columns, and what that means is the goal of Parquet is being able to do analytical queries for that information, to do aggregations. So that's the reason, because it's structured by columns instead of rows, because if you need to query that information, it's going to be a lot faster than query each row, right? So it's very oriented to read intensive processes, or processes where you need to do analytics or queries and things like that. Okay, and that's the reason because it's so popular in the Hadoop ecosystem. It provides some schema basic evolution capabilities. Things like you can see it as a table in a database. If you add a new column in the table, the queries against that table shouldn't break. Okay, this is exactly the same. If you add a new column, that's going to be compatible with the services processing that information. But if you delete a column, then the queries or the processes analyzing that information are going to break, because they're going to miss that column, right? The third one is Avro. Avro, it's also a binary format, and it's also part of the Hadoop ecosystem. Or at least it was initially. It was not very popular in the Hadoop ecosystem, but now it is used mainly in a different area. I will speak later about it. The difference, there are many differences, but I think there are two very important. The first one, it's row based. Okay, so it's not oriented to column, it's row based. And the thing, because it's row based, you have different records inside a file and they're sequential. So that's perfect for event streaming platforms. You want to have the benefits of binary protocol, but you don't want to do aggregation. But basically, you want to process the events individually, and for that, Avro is really good and it's really efficient. Okay. The other thing Avro is really good, it's in provide schema evolution management. Okay. Basically, because it's able to, inside the data Avro object, is able to include the schema definition. You may include the schema definition, or you may include an ID to be able to know what schema is in the data you are receiving, right? There are several ways to define those schemas. The most popular by far is JSON. It's oriented to machines, but it's also quite used for humans. The other one, it's Avro IDL, more oriented to human, but not so used yet. Okay, maybe in the future, but not yet. So the thing with Avro is that capabilities it gives you to evolve easily your data and evolve your schema without breaking compatibility with the services or the queries or the analytical systems using your data. Okay, that's probably the stronger point of this file format. Okay, so to do that, let me introduce the Schema Registry. Okay, Schema Registry is just it's a component. It's a service which is able to store the schemas. It may be in Avro, it may be in Protobuf, it may be in JSON schema, and acts as a source of truth for those schemas. So you have capabilities. You have a central system managing your schemas. Okay, so there are different vendors providing this. In the Kafka ecosystem, the most popular it's the Kafka, it's the Confluent Schema Registry, but Red Hat also has a service registry which has very similar features. IBM also have their own, so not there are several possibilities, and there is even a proposal from Microsoft trying to standardize the API. It's quite interesting space right now. So how it works that? Let me show you. You have a producer which wants to produce events to Kafka. So what the producer does in the first, before to publish the event in Kafka, is go to the schema registry to see if the schema for that specific data is already there. If it's already there, just track the ID and send the ID of the schema and the data. So whatever reads or consumed from Kafka is able to understand what data it is receiving, okay? Because it has a way to track the structure of that data. If the data isn't there, if the schema isn't there, the producer can register the new schema. Okay, so it has the possibility to publish that new schema in the registry. So when the consumer go to the registry, the schema is going to be there, and is going to be able to interpret that data. Okay. Also, that's an optional feature, of course. You can, in many cases, some people just disable that option, so you need to publish first in the schema registry using your SIA platform, for example, and they don't allow the producers to publish directly. Okay, but that depends of how you organize your architecture. Then, so you can produce. There is something interesting here. If you're going to produce an event with a defined schema, and you go to the schema registry, and the schema is already there, but it's different. What that's going to do, the producer, is say, okay, this is different, so let's generate a new version of the schema. Okay, so it's not just the idea of the schema, but also the version of the schema. And what's very important is in the schema registry, you can define rules to make sure the compatibility between versions of the schema. So you define a rule to make that schema backward compatible with the previous one. I will explain that later. And the schema it isn't, okay, the schema registry is going to reject that publication, and it doesn't allow the producer to publish to Kafka. Okay, in that way you are always going to make sure the consumers are safe processing the information. They are not going to break because the format is not compatible or is not following the previous agreed interface. Okay, so basically the produce, it's just sending information. We have in the schema registry ID the consumer, they go to the, when they receive data, they receive the ID, they go to the schema, and now they know how to deserialize in a safe way the data to process it and to make sure they are not going to break in any case. So it's very safe, and it's also very performance, because in most of the cases the producer or the consumer are not going to the registry for the data. They just have them in a cache, an internal cache. Okay, so they just need to go for the schema for the first measures, and for the rest one they don't need to do it again. Okay, so it's really performant. So let's take a look to the schema evolution thing. We are going to define three levels of compatibility. Okay, there are some more if you look into the schema registry products. Okay, but they are probably the most important, the more general. The first one is backward compatibility. So basically this means all data can be read with a new schema. Okay, so if you generate a new version of the schema and you use that version, you can just be able to read information from events which are in the old version. That means, for example, if we have this record, this is a Avro definition. As you see, is JSON, defines a namespace, and what's important here is define different fields, right? So we have the name, the fabric number, and the fabric color. Okay, as you can see, fabric color it has a default value, which is green. That means if we add this fabric color in the new schema, it's going to be yet backward compatible with the previous one, because the new, if you receive an all record, because fabric color is not mandatory, and you know if it is not present it should be green, you can just read an all record and say, okay, fabric color, because it's not present, I'm going to use green, and this consuming is not going to break. Okay, so that's important, and that's something you can just make enforce using the service registry. The other mode we have is forward compatibility. In this case, we want to assure new data can be read with the old schema. So basically, if we, for example, remove this fabric number, okay, the new schema isn't going to be forward compatibility, because the new data, okay, isn't going to be able to be read with the old schema, which has fabric number as a mandatory field. So the new data without fabric number is not going to be possible to be read with the previous schema. In the case with fabric color, it's not an issue, because fabric color it's optional. Then even if we have new data and fabric color is present, because it's a new field, it's not a problem. What it's going to do, my consumer, is just drop that value and use the rest of the fields, and it's not going to break. Okay, so we have backward compatibility, forward compatibility. If we apply both together, we have full compatibility, which is we have backward compatibility and forward compatibility. That's the best way to assure we don't break our consumers when we evolve data, but at the same time, it's also the most restrictive way. Okay. So, well, these concepts are not specifically for Kafka or for event-driven architectures. You can use them in whatever big data service which is generating information and consuming information later in time in an independent way. So the concept is really the same. You can use some service registry just to orchestrate and make sure the information is not breaking when it's received by your consumers. Okay. Just I'm going to mention AsyncAPI. If you work with APIs, with REST APIs, you probably know there is a lot of a big ecosystem for API management. So basically, you have Swagger and one API, which define how you are going to work in an API first model. When you define first the API, you agree with your consumers in that API, and once you have that agreement, you build your API. Okay, AsyncAPI, the idea is to do exactly the same, but with event-driven architectures, with asynchronous communication. So the idea is you are going to have like a meta model where you define your data, your asynchronous data. You can agree with your consumers on that data, and then you can work in the implementation. Okay, and this should be independent of the file format you are going to use. Okay, it's just metadata which helps you to define data schema. So it's a very interesting movement. Most of the service registries and platforms are evolving to support this in some ways and to copy that model, which is so successful in APIs, to the event-driven architectures, to the big data architecture. So yes, take a look, because I think in the next 1 year, a couple of years, we are going to speak a lot about AsyncAPI. Well, I was speaking here about different formats, but they are just examples. Okay, probably in my case, the most popular examples I work with But if you think in JSON, you have also CSV and XML, which are very similar in many ways. There are also text formats. Okay, they have some support for schemas. Depending, XML is better, CSV is worse. But I mean, they work in the same space, right? It says the same thing with Parquet, where has some competitors. Let me say that way. With RSC, and also with Protobuf for which is also very used in microservices and other type of microservice architectures and things like that. But it started being used as a Avro replacement in some big data architectures. The idea here is it provides similar features to Avro, but it's more popular in IT or development or service development thing. So you can have just Protobuf for everything and don't have your microservices with Protobuf and your big data systems with Avro. But that's just pretty new. Avro is yet a lot more popular in most of the architectures. So, well, that's all. Thank you for your time. Well, remember, you have the chat on the right. I will take a look now, or you can send us also questions by email. Okay, let me check, but I think there are some. Let me go with the questions. Okay, we have a question by email. How it works the service registry in terms of authentication? Basically, service registry is a REST API, so you can have validation as any other web API. In the case of the Confluent version, they already provide a plugin, a conversion plugin, which provides authentication authorization. If you use other implementations like the Red Hat, they don't have that type of feature. So you need to put something in front of them to add those capabilities on an API gateway, proxy, or something like that, which is going to give you that capability. That's almost mandatory because you don't want, in any case, to search to modify the schemas of other users, because it could be a problem. It could break the pipelines.